In this video, we will learn about the command design pattern and how to implement it using C++ code. Command is a behavioral design pattern, and it allows us to pass requests along through an invoker that accepts the commands as method arguments. By utilizing the command pattern, we can support operations like undo and also delay the execution of a command. For example, cut, copy, and paste are sometimes used in different orders. Sometimes we copy and then paste, other times we cut then paste, depending on our needs. Instead of hard-coding these operations, we can utilize the command design pattern so that we can specify a start and finish action with two of these commands, which will cause them to get executed in the order that we specify. Let's learn how to implement the command design pattern using C++ code. First, we will create a class named command. Inside of this class, we will create a public virtual void function named execute. Next, we will create a class named copy that extends the command class with public accessibility. Inside of this class, we will override the execute function, inside of which we will output the string copy command executed, and then a new line to the console. After that, let's create a class named cut, which extends the command class. Inside of here, we will override the execute function, inside of which we will output cut command executed, and then a new line to the console. Then we will create a class named paste that extends the command class. Inside of here, we will override the execute function, and inside of the execute function, we will output paste command executed, and then a new line to the console. Next, we will create the invoker class. Inside of this class, we will have a pointer to a command named onStart, and a pointer to a command named onFinish. Then we will use the public access modifier. Let's create a function with a void return type named setOnStart that takes in one pointer to a command named command, inside of which we will set onStart equal to command. Then we will create a function with a void return type named setOnFinish that takes in a pointer to a command named command, inside of which we will set onFinish equal to the command passed into the function. Next, we will create a function with a void return type named performCommands, inside of which we will check if an onStart command was supplied to the invoker. If so, we will call the onStart command's execute function. If an onFinish command was specified, we will call its execute function. Time to test our code. Inside of C++'s main function, we will create a pointer to an invoker named invoker that we set to a new invoker object. Then we will call the invoker's setOnStart function and pass in a new copy object. After that, we will call the invoker's setOnFinish function and pass in a new paste object. Then we will call the invoker's performCommands function. Next, we will output a new line to the console. After that, we will create another pointer to an invoker named invoker2, which we set equal to a new invoker object. We will call invoker2's setOnStart function and pass in a new cut object. Then we will call invoker2's setOnFinish function and pass in a new paste object. Finally, we will call invoker2's performCommands function. Before we run the code, there is just one quick adjustment to make. On line 8, let's mark the execute function as purely virtual by typing const equals 0. We need to do this since we use the override keyword to override this function in the classes that extend this class. So not doing so would result in a non-virtual member function marked override hides virtual member function error. When we run the code, notice that the first invoker performed the copy command and then the paste command. Then the second invoker performed the cut command and then the paste command.